You know, it's fascinating to think that before transistors and integrated circuits were everywhere, the first semiconductor devices were actually just diodes.
Yeah, that's right. They might seem pretty simple, but those little two-terminal components really were the foundation for so much of modern electronics.
I think you'd be surprised how versatile they still are even today. So let's take a look at exactly what makes a diode work and explore the important role they have in all different types of circuits.
Well, at its heart, a diode acts like a one-way valve for current. Kind of similar to a check valve if you're familiar with hydraulic systems. Current flows easily in one direction, that's what we call the forward direction, but is blocked in the other direction, the reverse direction.
So basically it's a gatekeeper, making sure current only flows where we want it to go and not where it might cause trouble.
Exactly. Now, most diodes you'll see these days are what we call semiconductor diodes, usually made from silicon. There were older types of diodes, things like thermionic diodes that use vacuum tubes, but those are basically a thing of the past.
Right. But let's dig a little deeper into how this one-way street actually works. We often hear about threshold voltage with diodes. What exactly does that mean?
Well, you can think of the threshold voltage as the on switch for the diode. If the voltage is below that threshold, very little current will flow. But once you go above that threshold, the diode starts conducting a lot of current. For silicon diodes, that threshold is pretty low.
So the relationship between current and voltage isn't linear. It's more of an exponential curve, right?
Exactly. A small increase in voltage above that threshold can lead to a big increase in current. And this nonlinear behavior is really important for a lot of the things diodes can do, especially when it comes to things like signal processing and power electronics.
So what happens if we apply a reverse voltage to the diode?
If you apply a small reverse voltage, it's fine. The diode just blocks the current as you'd expect. But there is a limit. When the reverse voltage gets too high, it can exceed the breakdown voltage.
And that's where things get interesting.
When you exceed the breakdown voltage, the resistance drops really fast, allowing a huge amount of current to flow in the reverse direction. This can actually destroy the diode if it's not built to handle it.
So it's like a dam breaking and suddenly current floods through in the wrong direction.
Yeah, that's a great way to think about it. Now, this breakdown thing isn't always bad, though. There's a special kind of diode called a Zener Diode that is designed to work in this breakdown region.
Wait, so they're actually made to break? That doesn't seem to make sense.
Well, it might seem odd, but Zener diodes use this controlled breakdown to do some useful things, like regulating voltage and protecting circuits from voltage spikes. So they basically sacrifice themselves to protect more sensitive parts of the circuit.
So they're acting like a pressure relief valve, diverting that extra voltage away from the rest of the circuit.
And this brings us to the huge world of ways we can use diodes. From converting AC power to DC to keeping circuits safe, these tiny components are incredibly versatile.
Speaking of applications, one of the earliest uses for diodes was in demodulating radio signals.
Think back to those old crystal radio receivers. At the heart of it all was a diode, often a point contact type made with a crystal like galena.
It's amazing that such a simple component could have such a big impact on early radio technology.
Yeah, it really is. That diode was what demodulated the AM radio signals. Basically, it pulled out the audio information from the radio waves.
So it worked like a filter, separating the music or speech from all the other radio frequency noise.
That's right. It was able to rectify the signal, converting it from AC to DC. That was the key to getting the audio separated from the carrier wave. Those crystal radios wouldn't have worked without that little diode.
It just shows how clever those early electronics pioneers were. They found a way to use a seemingly simple component to revolutionize communication.
And speaking of revolutions, diodes played a really important role in the early days of digital computing, even though people don't always realize it.
You mean in those massive room-sized computers? I thought they just used vacuum tubes.
They did. But before transistors were everywhere, diodes were actually what people used to build logic gates, the basic parts of digital circuits.
I had no idea. So how did they manage to use diodes to do that?
They used something called Diode-Resistor Logic. It's where you combine diodes and resistors to make simple logic functions like A and D and OR gates. But this technology had its limitations. It was kind of slow and used a lot of power. Eventually, transistors took over.
So diode-resistor logic became obsolete, but it's still interesting to see how people use these components to build the foundations for the digital world we live in.
It really does show just how incredibly versatile diodes are. But they can do way more than just rectification and early computing. They're also key for things like power conversion and circuit protection.
Let's explore those applications a little more.
Sounds good. So one of the most common ways you'll see diodes being used is in power conversion. specifically rectifying AC power to DC power.
Yeah, it's true that almost all of our electronics need DC power, but the power coming from our wall outlets is AC. So how do diodes make that conversion happen?
Well, think of a diode as like a one-way street for electrical current. In an AC circuit, the current is always changing direction, but a diode only lets it flow in one direction. It basically blocks the reverse flow.
So it's kind of like chopping off the negative half of that AC wave, leaving only the positive parts.
Exactly. And those positive pulses can be smoothed out even more using things like capacitors to get a fairly steady DC voltage. And this is going on all the time, from those little power adapters for our phones and laptops to those big industrial power supplies. And speaking of keeping things safe, diodes are also really important for protecting circuits from things like reverse voltage and those annoying voltage spikes. They're like tiny little bodyguards for our sensitive electronics.
Yeah, like having a safety net in case of any unexpected electrical problems.
Exactly. So let's say you accidentally connect a battery the wrong way around to a sensitive circuit. A diode can block that reverse current and stop it from causing damage.
And what about those voltage spikes you get from things like lightning or power surges?
Well, a diode can act like a pressure relief valve, diverting that extra voltage away from the delicate components.
Right, so like a miniature circuit breaker, basically sacrificing itself to save the rest of the circuit.
You got it. This is where those Zener diodes we talked about earlier come in handy. Their controlled breakdown behavior is perfect for voltage regulation and overvoltage protection.
Speaking of Zener diodes, their ability to maintain a specific voltage no matter how much current is flowing makes them really useful for things like voltage reference circuits.
Yeah, that's right. Zener diodes create a stable voltage reference, which can then be used to regulate other voltages in the circuit. You'll find them in power supplies, analog to digital converters, and lots of other circuits where having precise voltage control is really important.
So diodes are clearly super important for regulating and controlling power in different ways, but they're even more versatile than that. They're also used in some pretty unexpected applications like temperature sensing and radiation detection.
Yeah, you might think it's weird that a simple diode can be used to measure temperature. But remember that threshold voltage we were talking about.
Right. So how does the threshold voltage relate to temperature?
Well, a diode's threshold voltage actually changes a tiny bit as the temperature changes. When the temperature goes up, the threshold voltage goes down. This relationship is very predictable and can be used to make some simple but effective temperature sensors.
You can figure out the temperature of a diode just by carefully measuring the voltage across it. Pretty clever. So where would you typically find these diode-based temperature sensors?
You'll often see them in places where you just need a basic and cheap way to measure temperature, like keeping an eye on the temperature of battery packs motors, or even just the temperature of the environment.
Interesting. And what about detecting radiation? How are diodes involved in that?
Well, when ionizing radiation like X-rays or gamma rays hit a diode, it creates electron-hole pairs inside the semiconductor material. These charge carriers can then be detected as a pulse of current.
So the diode is basically converting radiation into an electrical signal that you can measure. That's really cool.
It is, and the stronger that electrical signal, the stronger the radiation. This idea is used in all kinds of radiation detectors, from the machines they use for medical imaging to the instruments used in nuclear research and environmental monitoring. Diodes are also used for things like signal clamping wave shaping logic circuits and even as light emitters in LEDs.
So from powering our devices to keeping them safe and even helping us explore science, diodes have proven to be really essential components. We've talked about a lot today, from how diodes work to all the different ways they're used. Before we finish up, we want to remind everyone that we're AI experts and we love bringing you interesting and informative content about technology.
If you enjoyed today's video, please think about subscribing to our channel and hitting that notification bell so you don't miss any future videos.
And be sure to give this video a thumbs up if you found it helpful. Your support means a lot to us.
We always love to hear from you, so leave your questions, comments, and thoughts below.
Until next time, keep pushing the boundaries of what's possible with technology.